Affordability. Of course, it's just as important as every speaker before me has mentioned. You may remember in the upper right-hand corner, I showed you this graph last year. And to quickly kind of go through the graph, it actually didn't say mission performance, it said performance. Made some slight changes. So if this were a build slide, I would say I have lived in the cloud for a long time. We have expensive systems, not because we like expensive systems, but because we wanted exquisite performance. And we had a long time to develop them. Now we neither have a long time to develop them nor the money to develop them. So imagine being asked or told to move to the left on the cost curve. And my thesis was that we would likely follow that blue line down and give up more performance per dollar rather than the green line be flat. And if we worked really hard, we could achieve that green line kind of linear reduction in performance. But really what we wanted to do was see us live on the red line. And that red line, the shape of that S there, you'd like to stay high as long as you can. And that's why I chose the word mission performance. Imagine that the blue and the green and the red originally as designed say performance. And when I think of performance, the way we typically measure it, it's in dBs, or it's some technical parameter, or it's distance. It's some technical parameter that is easily measurable, a metric that's well defined, and we understand how you develop systems to meet that metric. Now imagine, if I really want true innovation, what I do is define mission performance. I want to achieve a particular mission. You go figure out how to do that. By opening up the aperture, if you will, to innovation, you can think about, just like Marilyn said, you can think about other ways, more affordable ways of solving that problem. So that's the basis. The second story I'm going to tell is we've been here before. Well, we've been here before. And I don't know what percentage of the audience today is a technical audience, but I realize that 70,000 people in the corporation are technical, so I'm speaking to them principally right now. And what I'll say is that we've met this challenge before. I'd like you to think back, and think back to the Cold War, something we like to do apparently. Think back to the Cold War, and at the beginning of the Cold War, you know, at the end of World War II, we all felt pretty good as a nation. Baby boomers were a result, right? Life was good. We had just won a world war. We put a Marshall Plan in place. We started creating these huge economies in Germany and Japan. We had friends to the north, friends to the south, big blue oceans on each side. Felt pretty good about life. Pretty untouchable. Then all of a sudden, Soviet Union steals the bomb. Not good. We know what the bomb can do. We just dropped 2 of them. So imagine what would happen if they were able to use that weapon on us. Well, but they can't get it here. Beep, beep, beep. Enter Sputnik. Now all of a sudden, they have a bomb. They can launch things in space. Pretty soon they'll have intercontinental ballistic missiles. I'm scared to death. So let's put kids under desks and build bomb shelters and do all these things that some of us in the room experienced, right? We took on that challenge. We took on that challenge through the kind of things that I showed you there, through that cloud. We developed exquisite solutions. We believed, maybe not correctly in retrospect, but we believed that we faced a 10-foot tall Russian, a force that was so overwhelmingly powerful and in great numbers, and if they marched through the Fulda Gap, we got to use nuclear weapons to stop them. What are we going to do? But over time, we became comfortable, believe it or not, with something called mutually assured destruction, with technical capabilities that would be overwhelming to larger forces, to include a technology that was pioneered and developed by this corporation, called stealth technology. Imagine that you are facing 3 rings of double-digit SAMs, and inside these 3 rings are running around strategic relocatable targets in and around beautiful downtown Moscow. Right? That's another name for mobile nuclear weapons. I don't know where they are, and what if they do a first strike, and I don't know how to strike back, and this exchange is not going to be too good for us. So we developed a technology called stealth technology, which enabled us to fly fighters, but more importantly, the B-2, into beautiful downtown Moscow, take out these strategic relocatable targets, among other things. And we didn't win the war because of stealth. We won the war because of economics. But the technical capabilities that the United States and our allies had were certainly fundamental in enabling us to convince the Soviet Union that that wasn't a good future for them. And then when you add the economic challenge, all of a sudden the wall goes down. Right? And I'm going to submit that the same people who took on that challenge, which today, think back about it, the insurmountable fear that that represented. How do you take on that kind of technical challenge? Well, we work very closely with an organization called DARPA. In fact, some of us have spent a lot of time there. And DARPA developed this phrase called DARPA Hard. And DARPA Hard typically means a capability that's something like 10 times greater than the existing capability. So it's really revolutionary, not evolutionary at all, and something that's very difficult technically to do. And so since Sputnik, actually, DARPA was put in place after Sputnik to prevent surprise for the nation, but they also are the kind of far-term investment arm of the Department of Defense, DARPA.mil. DARPA is also looking at affordability, and although I don't think they have exactly used this phrase, I'm going to use it, and that is DARPA Hard for affordability, whereby we think about, and we won't do this on every program, of course, I'm using it as an example, but we think about DARPA Hard affordability where I'm able to maintain current performance at 1/10 the cost. Not easy to do, very difficult to do. Not possible in everything we do, but possible in some things we do. And it's possible if, in fact, you open up that ordinate of mission performance to allow innovation to occur and let people think differently rather than trying to get that last 0.3 of a dB. So, another initiative, the Engineering for Affordability initiative. Because I so strongly feel that it's the technical community that's going to help us solve this problem, we put an Engineering for Affordability initiative in place. All of the things that the previous speakers have talked about are absolutely right. We have to cut costs, we have to become affordable, we have to do all those things. I just feel that if you do the math, you will find that you can cut to zero all of the overhead and all those things, and you're still going to have problems meeting the challenges of what I think the future defense budget will look like. And it is only through a combination of doing those things and producing affordable weapon systems, really affordable weapon systems, that we'll get out of this. In the same way that we got out of the Cold War as we faced that challenge.